The whole humanity is on this boat. The boat is our built environment. Turbulent sea is the current endangered planet. And that's a leak. That's environmental crisis. How are we going to rescue the boat? And so the first thing we need is information and directive to take the boat to safety. The second is we need the means and equipment to do it. And so the information and directives, I see this as ecology. You create systems that will take you to safety. But the ecosystem is central to everything. Thank you for coming to listen to me talk. I'm going to talk about the work I've been doing for a few decades, which is essentially about designing nature. This was started with my doctorate thesis, dissertation, which then became my lifetime's agenda. It doesn't change. Okay. Well, I'd like to start by showing the current condition we are in. The whole world, I see, is on this boat. And the boat is in a turbulent sea. And that's a leak in the boat. So by analogy, the whole humanity is on this boat. The boat is our built environment. Turbulent sea is the current endangered planet. And that's a leak. That's environmental crisis. So that is the situation we're in. So the issue then, what are we going to do? How are we going to rescue the boat? And so the first thing we need is information and directive to take the boat to safety. The second is we need the means and equipment to do it. And so addressing these are the basic functions of my work. And so the information and directives, I see this as ecology, as applied ecology. Ecology is a science, but when you applied it, it's applied ecology. And that biomimicry is what I call a nature-based approach where you create systems that will take you to safety. So in a nutshell, this is what my whole lecture is about, my whole presentation is about ecology and about the constructed ecosystem. So if we start with nature, then nature sees the planet as covered by a thin film called the biosphere, where organisms live. Within this nature, there are biomes, there are ecosystems, the communities of plants and animals, the habitats, leading down to organisms. That, if you like, is the taxonomy of different parts of nature. But the ecosystem is central to everything. The ecosystem, for me, consists of biotic constituents and abiotic. Biotic means biological. Abiotic means physical. And so these are the basic constituents in the environment that we are working within. Now, a lot of these constituents interact with each other in very complex ways, but we cannot see it. You go outside, you look into a patch of green, you cannot see these processes taking place. And so there are a lot of things that take place in nature that we cannot see. We assume things that cannot see, but we need to be aware that if we upset any of these, we upset the rest of them. So that's what ecology is about. Then within nature, the species, that's us as human beings, we are the most powerful of all species. We can change landscapes, we can change waterways, now we can change, contaminate the sea, we can change climate. But what also makes us different from other species is that we make things. We make the built environment, and we make artifacts. In fact, we make more things than any other species in nature. Now that is the problem. What do we do with these things after you use them? You throw them away. Well, there is no away. The biosphere is a closed system, so they accumulate. The contaminated gases contaminate the atmosphere, contaminated liquids contaminate the waterways, contaminated the architects we don't want, the artifacts we don't want, contaminate the environment. And so these are the things that we do to the natural environment. It contributes to the greenhouse gases. And then added to this is our energy systems. You and I are addicted to energy. We cannot survive without energy. Just like this room, you cannot have this room without the air conditioning with this fan and the lighting. And so we need, but where does the energy come from? Energy comes from burning fossil fuels or burning gases. So we need to convert energy systems from non-renewable sources to on-site renewable resources. And this is what happens now. This is the situation we're in. Now, I tell everybody that we are in a terrible situation. We only got maybe about 10 years left. Nobody listens to me. Nobody wants to do anything. Worse, the people look the other way. And so, if I were to leave a single message with you before you leave this room, is that be aware of the current environmental crisis. Second message, please do something about it, because if we don't do anything about it, we won't have a planet left for us to survive. As I said to Paramiti, human species will die. But nature doesn't care, because nature will survive through succession over time. And so it is for survival, sustainability, and resilience of human society they're working towards. And so, in a nutshell, these are the 5 factors we need to consider. Nature, our human society, its happiness, well-being, and comfort, our built systems, the waste, reuse, recycling, and where they go afterwards, the energy systems, that we need to reduce dependency on non-natural resources. And then there is hydrology, the water that has to go somewhere. And so this is too complex a drawing that I want to go through. But ecological design is how we integrate these 5 factors into a whole. That is the challenge of eco-design. I haven't been able to answer all of these questions, but that is the agenda of my lifetime. So back to this drawing of about our condition. And one of the things we need to look at is biomimicry. Let me see, okay. I'm sorry, this is a bit of a mess. So, oh, sorry. I'll keep going forward instead of backwards. And so the basis of my work is how to build constructed ecosystems. So I'll start to look at the properties of ecosystems. We need to imitate nature. This is what nature-based design is about. And so I start to list down what are the properties of nature we need to imitate. On the right-hand side are different steps we can imitate nature. The first one is replicate, means we reproduce nature in our built environment. The second is emulate, copy as much of nature as possible. Third is to cooperate with nature, augment nature. And fourth is to intensify. So these are the basic key factors we have to design. It's not comprehensive. The one I have on the left-hand side, on the middle, are these different steps we have to do. So the first thing I look at is the biological structure of our built environment. Now, this diagram I showed earlier on. What is clear is that everything in our city is abiotic. Mumbai, that you today, 99% of the city is abiotic. But nature has has a constituents of biotic and abiotic. And so what we need to do is to see how we can bring it together in our work. And so this was the starting point for me when I started designing. So now how do we bring nature, how to bring habitats into our built environment? We can put it all one location, as you can see this diagram. You can have a spotty relationship, like in Georgian London, where you have a number of squares, Tavistock Square, Bedford Square, Euston Square, Russell Square. You can have a series of stepping stones. You have squares which are green areas which are not connected, but close enough for certain species to move across from one patch to another patch. That's not satisfactory. I call it a stepping stone. The third is the tree, where you have a spine with fingers coming out. And the fifth is much more satisfactory because the ecological factors, the habitats are linked. By being linked, species can move from one part to another part, whereas if you look into the stepping stone or the first diagram, species cannot move from the ground up the building. And by being connected, enable a larger pool of common resources to share among the species. By having a larger common pool, it engenders a higher level of biodiversity. By having a higher level of biodiversity, it engenders a much more stable ecosystem. Of course, the ultimate is this one where the whole of the building covers with plants. But to me, these two are the preferred patterns, the spiraling pattern or the infused pattern where the whole building is covered with vegetation. So with this as the starting point, I started to explore this in my built work. And so in many ways, our practice is one of thinking about ecological design, converting into patterns and converting the patterns into plans, converting the plans into buildings, and then we look back and say, what do we do right or we do wrong? And so within the buildings itself, we create secondary habitats on the roof, inside the building, on terraces, on the ground, and in the basement. So the diagram on the left-hand side illustrates the different types of habitats. But then continuity is important. So that's the fourth factor, third factor, because in nature, everything's continuous. What we as human beings do is we fragment nature. We go a piece of nature, we chop it up. We put walls, we put fences, we put roads, we put drains, we chop up nature. And so what ecological design should try and do is to reconnect nature, not just in the ground, but vertically up in the air as well. And so in this way, then we re-green the city, we make the city in a constructed ecosystem. So this is a scheme we designed in Singapore, and this is Waterloo Road. And this was the early precursor of the continuous ramp. The ramp starts from the ground, it weaves its way around the outside of the building, going up to the top of the building. And that when you reach certain parts of the building, I create large skycars with greenery. And then within the greenery, where the ramp reaches the same height as the joining building, I bridge across. So we green the roofs of the bridge of the buildings next door. In this way, the building then becomes a device for making the city green. I mean, nobody's adopted it, but that's the idea. So then with the last pattern, this is a data center we did where we brought the vegetation continuous from the front facade to the east, to the west, to the south, and to the west, and back again. And so this was the data center where we had a green wall going all the way up, and it's continuous, and that on the facade. And then this is a building in Singapore where this time we implemented the vegetated ramp, which is, with each floor we had a vegetated ramp that with each floor we climb one facade. And so this was the idea, this was the concept diagram. And here you are, you can see the ramp and you can see the vegetation. And that the vegetation also serves the other purpose of phytoremediation. Phytoremediation is absorb the pollutants in the air. So the building then contributes to improving the environmental quality. So this was the early concept diagram we did. The idea was to have the plants, the walkway, and the building. Now, next time you look at a building done by another architect who puts vegetation buildings, most architects, to get access to vegetation, they have to go through the internal usable area. That is really annoying for the users. And so in order to address this, I put a walkway next to the plants so you can service the plants without going through the building. And then because the walkway is a ramp which is continuous, I call this a linear park. And I'll explain what this means later on. And so here this was built. It took about 5 years from the earlier building that I did down to, we got this building. And so you have to be persistent with your ideas. In many ways, architecture is an old man's game. It takes a while to get to do what you want. And so here's the building that was completed in 2006, actually 2009, I think. And you can see that the ramps going all the way around. But where the ramps hit the corner, I opened it out to create a sky cone. And this is the building seen from a distance. You can see the third building in the middle. The building on the far left is designed by the famous Japanese architect, Mr. Kurokawa. This is the ramp. You can see it going up each facade. And then we have a number of green roofs. You have the main one, which is the mid-level roof, then a series of secondary terraces. And then you have this is the mid-level roof, and this is the green garden at the top of the building. And this is the building seen from the south. But at the corners of the building, we punctuated by opening it out to show balconies like these, so that people from inside, it's like a mini plaza with the linear park. Linear park goes up the building, you have mini plaza, then go up again, another mini plaza, and that people from inside of the building can interact with those on the outside. And so, it's a place where you can have a cigarette, you can have a cup of coffee or your breakfast or your meal, and there it is in the corner. But the other thing we did was to see whether we can bring the ramp down to the basement. So you can see the red square. That's where we brought the ramp down to the basement. I call this the eco cell. So the ramp continues all the way down the ground floor and continues all the way down to the basement. And this is what it looks like. You can see the vegetation, see the walkway, and this goes all the way down to the building. I call this the eco cell because right at the bottom, you can have a bioswale, or you can have a living machine designed by my friend, John Todd. Now, interestingly, the building, even though it has a single facade, is basically 2 blocks linked by bridges. And so in between the bridges, I have an atrium. So you can see the glass atrium, and this is looking up from the atrium. Now, this is what makes the building low energy, because this atrium is not air conditioned. You just have cold air being blown in. And then we have a number of experiments. We have what you call a diagonal light shaft. You see the void. This is the atrium, the glass roof, when it rains. On a normal day, it is open to let the air out. So this becomes what I call a mixed mode space. And then I have, on the left-hand side is looking up at the atrium. On the right-hand side is the diagonal light shaft that you see, which cuts across all the floors. Oops. Yeah, this is looking down at the diagonal light shaft. You can actually see the street level from some of those levels, and this is from street level looking up to the skylight at the top. These are one of the bridges that link the two blocks together. And here you can see the one block, and this is the second block. But the plan on the left-hand side shows the two blocks, and the red square shows the bridge that links the two. This is the daylight simulation of a typical floor. It just shows that the floor isn't a very good floor because you have dark areas. The distance between one glass wall to another glass wall is about 30 meters. Whereas in Germany, most buildings are long and narrow because you cannot have one glass wall and the other glass wall more than 7 meters apart, because in the middle of the floor of an office building in Germany is about 7.5 meters. You must be able to get daylight into the middle of the building. Now, somebody asked me earlier on, what is the ratio of greenery to the area of the building? In Singapore, they have this thing called the Green Area Index, where the minimum is 6. This building is 12, so the green area, which is in a flat area, is 12 times the ground floor area of the building. So to me, a rating system is just only a tabulation that you must exceed, whether it's LEED or BREEAM or CASB or Green Mark. You should try to exceed as much as possible. So on the left-hand side, as you can see, are those ecosystem properties we should try and emulate in our design. So that is my personal agenda. I haven't been able to achieve this 100%. On the right-hand side, under biomimicry, there's the different strategies for adopting these properties. But one of the things I do when I look at a site for the first time, I look at what latitude it is. What is the biodiversity of that location? And so I look at Mumbai, and Mumbai is, I think, around 30 degrees latitude. So it's a fairly biodiverse location. And we should try and protect this biodiversity. So this is a building that we did in Putrajaya, which is the capital of Kuala Lumpur. And we had a series of sky courts. You can see the sky courts which are composed. And then within the sky courts, we are planting. And then it lies on the axis from the plaza down to the waterfront to a tower which is called the Millennium Monument, which was also designed by us about 8 years earlier. The two buildings are almost symmetrical, and because of the axis through the middle, what we could work with was the leftover side to side. And then the first thing we designed is, you can see in the top row, is to create habitats within the building. Habitats on the center, in the ground, habitats in the sky courts, habitat on the facade, habitat in the terraces, habitats inside the building, and so forth. And so, having designed habitats, we try and identify which are the faunal species that we want to bring back. This is species that existed in that locality, which we removed by clearing the land. When we got the land, all the vegetation was removed. And so the second approach is to design, identify the faunal species that we want to bring in. And then this is analysis of the species, both the flora and this is the faunal species in Kuala Lumpur. And then we use this as a guide to design the biodiversity targets, so habitats, faunal species. The next is to identify the floral species that will attract the fauna. And so having done this, next is to look at how these interact with each other, and then the interaction then becomes the basis for us to design the habitats and the pleasurable zones for people who use the building. So in effect, this is our biodiversity targets approach. Now this project is a medium-rise building. So how do you apply it to a high-rise? And so we start to look at the biodiversity aspects. This is the eco-cell that goes all the way down from this building, going down to the basement. And then the eco-cell idea originated about 5-6 years back when we did this competition for the Kowloon waterfront. So competitions, for me, are never wasted effort. They're research for ideas that we can use later on. And so when we did this competition, we had a series of eco-cells you can see in the red square. And these ecocells do a number of things. It brings vegetation down to the basement, brings daylight, brings natural ventilation, brings rainwater harvesting. And last at the bottom, we could have a living machine or a biosphere at the bottom. And so this was the early experiment that we did about 5-6 years earlier. And we just kept the ideas in our head. And then we implemented this in the Solaris building. And then we brought this into the Putrajaya building. The next thing is you're talking about designing in the tropics. In the tropics, the sun is east and west. You have a hot east sun and hot afternoon sun. And certain times of the day, the sun is a little bit north, certain times a little bit south, on east and west side. And so the conventional approach to sunshades, to protection from the sun, horizontal sunshades. We thought maybe there could be another way to do this. So the idea we had was to use fritted glass, not butt jointed, but with an air gap, so that air can go through. And that fritted glass is on the facade, and then I have a walkway in between. Outside, you can see in the diagram right-hand side, you can see the fritted glass, the fritted glass facade. The fritted glass becomes almost a sun shading, and then inside is the actual facade for the interior. And the cultural aspect is very important. And so we took the headdress of the royalty in Malaysia, and they used a pattern of golden threads called a socket. So you can see the socket right inside. And so this became the pattern that we printed onto the fritted glass, but it has to be about 50% of the fritted glass to be effective as a sunshade. And so that is the fritted glass. And then on the west side, we angled it a little bit to address the western sun. And then you can see the walkway in between, so you can service the fritted glass on the outside and the inside. And then you can see the detail of the walkway. But looking out, this is what you see. You see the fritted pattern, where it doesn't quite block the view. It blocks some of the view, but not entirely, but you still see the outside. So that is the concept for the experimental sun shading. Now, the normal office building uses 120-something kilowatt hours per square meter per annum. This one uses about 70-something. So by almost the purposes, it's about 75% less. And so it's a low-energy building in that sense. And this is the west facade. This is the west wall. But the building lies along the axis, as I mentioned, from the plaza all the way down to the waterfront. The waterfront is that red square. Is the Millennium Monument, which was also designed by us about 8 years earlier. So here's the monument. You can see the axis. The main axis, the long one, is the boulevard in Putrajaya, which is the capital city of Malaysia. It leads to the Prime Minister's office, which is at the end. So on the top right is the Prime Minister's office. And then the second axis is the one that goes to the waterfront, where the monument is. And then the monument, adjoins the, well, this is before we did our building. This is the Ministry of Finance building done by a friend of mine. And then the icon of the cultural aspect of the monument is that we wanted to have a ramp going all the way up. And the monument plus the ramp is derived from the hibiscus flower, which is the national flower of Malaysia. You can see the petals, you can see the stem end. And so this was, if you like, the cultural factor for this project. So for me, a building is a building. Yes, form making is important, but if you don't reflect the cultural factors of the place, it could be built anywhere in the world. And so addressing the cultural locality is important. And so back to this diagram where we had the tree and the sky courts. This is the building. It's an apartment building for about 300 units apartment. You can see the tree in the middle, but it opens out into a series of sky courts, which becomes areas of respite for the users. The users don't just live in an apartment, and then it's almost inhuman, in the apartment. They need spaces they can go out to, need to have breakout spaces, need spaces where they can meet with their friends. And so we have 5 sky courts on the facade. You can see but the vegetation goes all the way up, then it diverts into the sky course. Now, before we did this, what I should have shown you earlier on is that the first diagram shows research on ecology in the proximity of the site. And then secondly, we look into diagrams ecology of the green areas near the site. From these two analyses, then we have clues on what to bring in. So what we did in this project is that we brought birds back into this locality. On the lower floors is the butterflies and dragonflies. The middle are the songbirds, and on top are the migratory birds, and the middle are the different faunal species that attract the birds, and these are where they're located in a section of the building. And so this was the approach. The top of the building we create into a real playground for the users. We have 4 types of swimming pools. We have the lap pool, which is number 1. We have the family pool, which is the children's pool, at number 2. The family pool at number 3, and then the jacuzzi pool on 4. So this, then in addition, we have 5, 6, 7, 8 are the pleasurable zones. We have eating areas. We have a mini theaterette. The whole of that top floor became a recreational floor for people, and so it has the iconic roof, and that's the building. That is the design for that building. It's under construction now. It's due to be finished in January, and it is. I was forced to buy a unit there, so I had to buy a unit as the architect. Now this is the IBM building that we did back in 1985, and this is an exemplary example of the diagram at the right side, which is the planters, which are stepping stone. The photograph looks as if they're connected, but what connects the two is the trellises in between. So it wasn't satisfactory. But this is 1985, 86, and we said this eventually led to the continuous vegetated building. And sorry, this is the we're going backwards here. Why are we going? Oh, sorry. I'm instead of going forwards, I'm going backwards. And then around about the same time, 87, we did this building where it has a series of sky courts. So the sky courts are in the corners, but again, the planting is not connected. But this building became for us an experiment in bio-climatic towers, because you can see the core on the left-hand side is on the west side, and the escape stair and the service course on the right-hand side, and both of them have natural ventilation. Now it's very important because if you have the core in the middle, you have to pressurize the lift shaft, you have to pressurize the toilets, you have to pressurize the lobby. Pressurization means you have to continuously have a duct that sucks the air out in case there's a fire. So in this way, the lift lobby is naturally ventilated, and so are the staircases and the toilets. But on the right-hand side is a study that shows different configurations of floor plate and different positions, the yellow different positions of the lift course, and the one on the red is a mirror of the one of the floor plate, and this is the lowest air conditioning cost for high-rise buildings in the tropics. I think it applies to Mumbai, but you're a little bit above the equator, so you need to adjust it a little bit. Now, people talk about designing a net zero energy building. This is my process. You start from one, which is a bio-climatic. Now, those you respond to the climate, and there I have a list of different ways you could do that. Second is mixed mode, where you have some technology. Third is full technology systems, where it has to be smart and low energy. Fourth is productive mode, where you produce your energy through photovoltaics or through wind energy. And 5 is net surplus energy. In a nutshell, this is the process for designing net zero energy to reduce the dependency on renewable resources. So the first one is Now, this is the temperate climate in this cold winter. Bio-climatic design can improve the comfort condition a little bit, not an awful lot. Mixed mode means some mechanical systems, and then productive mode is using photovoltaics and wind energy, but it's almost extremely difficult to reach the consistency of red color, which is what engineers want us to do because that's a high energy situation, but it's not impossible. So this building is a passive mode design building where you can see the building on the right-hand side. The pool becomes a evaporative cooling device, and then the canopy becomes a shading device. Outside temperatures are 35, pool is about 32, inside the building on the ground floor is 30, and the rooftop is 33. I still haven't been able to reach 27 yet, but I could if I use mixed mode. And this is a station in China, but the fritted facade I have on the Putrajaya building, I flip it on horizontal, so this becomes a horizontal sun shading. It can't be like the other one. This is a building where we had a shaped roof. This is a convention center. This time we had operable roof that could let the sun and the daylight in, and the plaza has a rainbow skylight. This is in London where the temperature inside and outside the buoyancy enables the air to be sucked up. So we created a glass ductile facade of the building. At the bottom is a valve, and this is in design in a temperate climate. And this is a building where we use ceiling fans and side throw fans to create a comfort condition. On the left-hand side is what the client existing building. On the right-hand side, the yellow is the use of mixed mode to cool the building, and that's what. So I'm going to end in a minute. And this is the data center under construction now. We put photovoltaics. The photovoltaic has to be about 50% of the net area of the area you want to use air condition, where you want to use the energy. And so this explains we suck the canopy out to get the area that we want. This is designing for happiness. I don't want to go into this, but essentially it's about how the brain gives out certain chemicals when you feel happy. Second column is the activities that generate a release of these chemicals. And the third is how it is applied in design. This is design eco-city. This is a diagram that shows that no matter how many green buildings you can build, but if the city's infrastructure is not green, the city will never become green.